Every image of the universe you have ever seen is incomplete. Not wrong exactly, just incomplete in a way that your brain almost cannot notice. A galaxy spirals in darkness. Stars glow in scattered clouds. Nebulae bloom like illuminated smoke. Clusters of galaxies stretch across black emptiness, like islands floating in an invisible sea. The image feels familiar, vast certainly, beautiful perhaps even overwhelming, but still understandable. Your mind accepts the picture because it resembles something human, objects existing inside space, matter suspended in emptiness, things arranged inside a container called the universe. This assumption feels so natural that we rarely examine it. The universe is here, space is the stage, galaxies are the actors. Time moves forward, reality expands. Simple, comforting, almost certainly incomplete, because there is a question hidden beneath modern cosmology that sounds less like science and more like forbidden philosophy. What if the universe is not the container? What if the universe is the thing being contained? Tonight, as you sit inside a room built by human hands surrounded by walls that define the limits of your immediate world, it feels obvious that boundaries are physical things. Rooms have walls, planets have atmospheres, solar systems have gravitational spheres of influence, galaxies have halos of dark matter extending far beyond visible stars. Boundaries feel fundamental, but the largest boundary in physics is unlike anything humans evolved to imagine. You cannot touch it, you cannot travel to it, you cannot observe it directly, and yet it may define everything. Physicists call one such boundary an event horizon, a deceptively calm phrase. An event horizon is not a wall made of matter. It has no surface you can stand on, no visible edge, no warning sign suspended in space, and yet once something crosses it, no signal, not light, not information, not causality itself can return. Beyond that boundary, the universe changes category. Not difficult, not dangerous, different. The rules that allowed prediction begin to fail. Cause and effect begin to warp. Distance stops behaving like distance. Time stops behaving like time. And what makes this unsettling is not merely that black holes exist. It is that the mathematics describing them has repeatedly led physicists toward a possibility so strange that even now it remains psychologically difficult to hold in the mind. The possibility that black holes do not simply destroy. They create. Imagine for a moment that somewhere beyond the visible universe, in a reality forever inaccessible to us, a star far larger than our sun collapsed under its own weight. Its core imploded, space folded inward, matter compressed beyond anything atoms were designed to survive. Gravity intensified until escape itself became impossible. A black hole formed. That much is accepted science. But now follow the mathematics one step further. What if the collapse did not end in destruction? What if inside that gravitational catastrophe, space-time did something else? What if inward collapse became outward expansion? What if what appears from outside as a black sphere swallowing light appears from inside as something unimaginably different? Not death. Birth. A beginning. A big bang. A big bang. This is where intuition begins to fail in slow motion. Because black holes feel local. They belong in distant galaxies feeding on stars sitting quietly in galactic cores. Our universe feels total. Everything. By definition, nothing should exist outside everything. And yet modern physics contains equations that do not entirely forbid such a possibility. In some interpretations, the Big Bang does not need to be the absolute beginning of existence. It may instead be a transition, a crossing, the interior emergence of a new space-time region born from collapse elsewhere, a universe inside a black hole. Pause long enough for that idea to settle. Every mountain on Earth, every ocean, every fossil, every civilization, every human memory, every extinct species, every cathedral, language, empire, prayer machine, satellite and star, all of it, not floating freely in independent reality, but existing inside the interior geometry of a black hole embedded in something larger, something outside, something unreachable, something whose sky we will never see. There is a particular kind of discomfort that comes from scale. We felt it when we learned Earth was not the centre of the cosmos. We felt it again when we learned the Sun was one ordinary star among hundreds of billions inside the Milky Way. Then again when we discovered there are hundreds of billions, perhaps trillions of galaxies. Each discovery reduced human centrality. Each widened the stage. But this idea does something different. It does not merely make us smaller. It changes the architecture of reality itself. Because if our universe exists inside a black hole, then the cosmos is no longer the final stage. It becomes a structure inside another structure, a nested reality, a chamber within something larger. And suddenly the oldest human fear returns in scientific form. Not fear of monsters, not fear of death, fear of enclosure. The fear that what seemed infinite is actually bounded, that beyond what we call reality lies another inaccessible layer, another outside, another silence. Look up at the night sky. The stars appear serene, ancient, distant, but their calmness hides something unsettling. You are looking at light moving through a universe whose true shape remains unresolved. The cosmos may be expanding into nothing, or into itself, or perhaps not expanding into anything at all. Perhaps what we call cosmic expansion is the internal geometry of a much larger collapse occurring somewhere we cannot conceive. And if that sounds impossible, that reaction is worth noticing. Because human intuition evolved to understand falling rocks, moving animals nearby weather and visible horizons. It did not evolve to understand curved spacetime. It did not evolve to understand singularities. It did not evolve to understand realities nested inside gravitational collapse. Which means the greatest obstacle in understanding the universe may not be missing data. It may be the architecture of the human mind itself. And that is where the deeper journey begins. Because before we can confront whether our universe might live inside a black hole, we need to examine something more familiar. The picture of reality most of us carry without question. The map we inherited. The comforting model that tells us what the universe is supposed to look like. Because the unsettling truth is this. That familiar picture is far less stable than it appears. For most of human history, reality felt local. The world was what could be seen from a hilltop crossed on foot or measured by the time between sunrise and darkness. The ground beneath human feet felt still. The sky felt close. The stars appeared fixed in a perfect dome, rotating above Earth with mechanical certainty. That picture persisted not because humans were foolish, but because it was sufficient. It predicted seasons, guided agriculture, enabled navigation, and offered psychological comfort. Humanity occupied the centre. The heavens revolved around us. Existence had structure, hierarchy, and meaning. Then the picture began to fracture. Nicholas Copernicus suggested Earth was not the centre. Galileo Galilei looked through a telescope and found moons orbiting Jupiter, proving not everything circled Earth. Isaac Newton showed that the falling apple and the orbiting moon obeyed the same law. For the first time, heaven and earth became part of one unified physical system. This was revolutionary, but still emotionally manageable. The universe became larger, yes, but it remained understandable. Space was empty. Matter moved through it. Gravity pulled objects together. Time flowed equally for everyone. Reality remained a stage with clear rules. By the 20th century, humans had built an astonishing cosmic map. Earth became one planet orbiting an ordinary star. That star, our Sun, belongs to the Milky Way, a spiral galaxy roughly 100,000 light-years across. Numbers like that are easy to say and difficult to feel. Light travels at nearly 300,000 kilometers per second. In 1 second, it circles Earth more than 7 times. In 1 minute, it crosses the distance from Earth to the Moon. In 8 minutes, sunlight reaches your skin. But to cross our galaxy, light requires 100,000 years. The light leaving one side of the Milky Way began travelling when early humans were still painting caves. Entire civilizations rise and vanish in the time a photon spends crossing a single galaxy. And our galaxy is not unusual. It contains perhaps 100 to 400 billion stars. Around many of those stars are planets, Around some of those planets may be oceans, atmospheres, chemistry, weather, perhaps even life. Already the scale begins to strain human intuition, but the map expands again. The Milky Way is not alone. It belongs to the Local Group, a gravitational family of more than 50 galaxies, including Andromeda Galaxy, our nearest large galactic neighbour. Its light takes about 2.5 million years to reach us. The photons entering your eyes from Andromeda tonight began their journey before modern humans built cities, before writing, before agriculture, when human existence was still fragile and scattered. Yet even the Local Group is a tiny structure. It sits inside larger galactic clusters. Those clusters form filaments. Those filaments form the cosmic web, the largest known structure in the observable universe. Imagine billions of galaxies arranged not randomly but like glowing veins across unimaginable darkness. Between these filaments lie vast cosmic voids, regions so empty that millions of light years may pass with almost nothing inside. This is already far stranger than the human mind prefers. We like continuity. We prefer worlds filled with substance. But the universe is mostly emptiness, not poetic emptiness, literal emptiness. Almost everything is nothing. If the atoms making every human who has ever lived were compressed into solid matter, with no empty atomic space, humanity would occupy a volume smaller than a sugar cube. Matter feels dense only because electromagnetic forces prevent atoms from passing through each other. Even your body is mostly emptiness held in delicate structural tension. The same is true on cosmic scales. Stars are separated by distances so enormous that even inside galaxies most regions are effectively void. And still the universe grows larger. Modern cosmology tells us the observable universe stretches roughly 93 billion light-years across. Notice the phrase carefully observable universe, not universe, observable universe. That distinction matters more than most people realize. The observable universe is not the totality of existence. It is simply the region from which light has had time to reach us since cosmic expansion began. Beyond that boundary, reality may continue indefinitely. There may be more galaxies, more structures, more emptiness, or something stranger. We do not know. This ignorance is often hidden by illustrations. Textbooks show the universe as a sphere, often from an impossible outside perspective, as if one could step back and photograph reality itself. But no such viewpoint exists. No one stands outside the universe. No camera can capture totality. Every cosmic map you have seen is a conceptual diagram built for human comprehension. Already there is a subtle psychological deception. We think we understand the universe because we can draw it. But drawing a model is not the same as comprehending reality. Human cognition depends on analogy. We understand new things by comparing them to familiar ones. Atoms became miniature solar systems, space became a grid, time became a line, galaxies became islands. These metaphors help, but eventually they fail, because reality at sufficient scale stops resembling everyday experience. And this is where comfort begins to return strangely enough, because despite its vastness, the standard model of the universe still offers reassurance. It tells a coherent story. Around 13.8 billion years ago, the universe began in a hot, dense state. Space expanded, matter formed, stars ignited, galaxies emerged, heavy elements were forged in stellar cores and supernovae. Carbon, oxygen, iron, calcium, all the chemistry required for life was born inside ancient stars. Eventually planets formed, life emerged, consciousness appeared. Human beings looked back at the cosmos that produced them. It is a beautiful narrative, elegant, structured, intellectually satisfying. The universe begins with a big bang. It expands, it evolves, it continues. There are mysteries, yes, but the broad architecture feels stable. Space contains matter. Time moves forward. Physics governs all. This is the mental model most educated people carry. It feels modern and scientific, but there is a quiet problem hiding inside this comfort. The model works extraordinarily well at large scales. It predicts cosmic microwave background radiation. It explains galactic clustering. It matches observations with remarkable precision. Yet when we push the model toward extremes, toward the beginning of time or the interior of black holes, something disturbing happens. The equations stop cooperating, infinity appears, density becomes unbounded, curvature becomes infinite. Physics, the framework we trust to describe reality, begins returning impossible answers. This is where the familiar map starts to crack, not dramatically, not with explosions or paradoxes, quietly, mathematically. The equations remain elegant until they approach certain boundaries. Then suddenly they describe places where space compresses into impossibility and time loses meaning. What most people never realize is that the greatest discoveries in cosmology have not made reality simpler. They have made it stranger. Every layer of understanding has removed another intuitive assumption. Earth is not central. The sun is not special. Our galaxy is ordinary. Visible matter is only a small fraction of cosmic content. Even worse, roughly 95% of the universe appears to consist of dark matter and dark energy substances we infer through gravitational effects, but do not fully understand. Think about what that means. Everything humans have directly experienced across all of history, every ocean, forest body, civilization and machine represents only a tiny fraction of total cosmic content. Most of reality remains fundamentally mysterious, and this leads us towards an uncomfortable realization. The universe humans think they understand may be only the visible surface of something far deeper. Because the closer physics gets to fundamental reality, the more familiar concepts begin to fail. Space fails, time fails, distance fails, even causality begins to bend. And nowhere does that breakdown become more severe than in one of the darkest structures in the cosmos. A region where our ordinary picture of reality stops working almost completely. A black hole. That is where the first real fracture appears. The first place where the universe stops behaving like a container and starts becoming something far stranger. Black holes were not discovered by telescopes. They were discovered first by mathematics, which is often how reality announces its strangest truths. Long before anyone observed evidence of one, the equations already hinted that nature permitted objects so extreme that even light could not escape their gravity. This idea initially felt absurd, even to physicists. After all, gravity was supposed to pull, not imprison. Light was supposed to move freely through empty space. The notion that space could curve so violently that escape itself became impossible felt less like physics and more like metaphysics. Yet the mathematics refused to soften. In 1915, Albert Einstein published general relativity, a theory so radical that it permanently altered humanity's understanding of reality. Newton had described gravity as a force acting between masses across space. Einstein proposed something deeper. Gravity, he said, is not a force in the ordinary sense at all. Matter tells space-time how to curve, and curved space-time tells matter how to move. This sounds abstract until you confront its consequences. Space is not empty background. Time is not universal flow. Together, space and time form a flexible fabric that bends, stretches, warps, and responds to energy and mass. This means planets do not orbit stars because invisible strings pull them inward. They move along curved paths through distorted space-time. Earth is not being dragged around the sun. It is falling continuously through curved geometry. Already ordinary intuition begins to fail. But Einstein's equations allowed far more extreme solutions. In 1916, just months after general relativity appeared, Carl Schwarzschild solved Einstein's field equations for a perfectly spherical mass. his solution contained something deeply unsettling. If enough mass were compressed into a sufficiently small radius, spacetime curvature would become so severe that a boundary would form. Cross that boundary and all future paths point inward. Not some paths, all paths. This boundary became known as the Schwarzschild radius. For Earth, that radius would be about 9 millimeters. Compress our entire planet into something roughly the size of a marble, and Earth would become a black hole, the same mass, the same atoms, but packed so densely that escape velocity exceeds the speed of light. For the Sun, the Schwarzschild radius is about 3 kilometers. Compress the Sun into a sphere the size of a small city, and sunlight would vanish forever. These comparisons are emotionally useful because they reveal the absurdity of black holes. They are not merely heavy objects. They are density taken to a limit where space-time itself changes character. But where do such objects come from? Nature provides a brutal mechanism. Massive stars live violent lives. For millions of years, gravity pulls inward while nuclear fusion pushes outward. This balance sustains the star. Hydrogen fuses into helium, helium into heavier elements. Pressure counters collapse, but stars are temporary truces against gravity. Eventually fuel runs out. Fusion weakens, pressure drops, gravity wins. For smaller stars, collapse stops at white dwarfs or neutron stars, but for sufficiently massive stars, nothing remains strong enough to resist inward compression. The core collapses catastrophically. In less than a second, matter falls inward at extraordinary speed. Electrons and protons are crushed together. Atomic structure fails, nuclear resistance fails. If mass remains above critical thresholds, collapse continues without known stopping mechanism. A black hole forms. This is often imagined as an object sitting inside space like a dark sphere floating in emptiness. That image is useful but misleading. A black hole is not simply a thing, it is a region where geometry becomes extreme. And the most psychologically disturbing feature is not the singularity at its center, it is the event horizon surrounding it. The event horizon is often misunderstood as a physical surface. It is not. If you are falling toward a sufficiently large black hole, you might cross the event horizon without immediate sensation. No wall, no flash, no visible barrier. From your local perspective, physics feels normal, and that is precisely what makes it unsettling. The horizon is real, yet invisible. It is a boundary defined not by matter, but by causal structure. Outside the horizon, escape remains possible. Inside, every possible future leads deeper inward. To understand this, imagine all possible directions through space-time as arrows pointing toward the future. Normally, some future paths lead left, right, forward, away. Freedom exists. Near a black hole, these arrows tilt inward. At the event horizon, every future arrow points toward the center. Inside the horizon, moving toward the singularity becomes as unavoidable as moving toward tomorrow. This is the critical psychological break. We think of falling into a black hole as moving through space, but deep enough inside moving toward the center is no longer like traveling north or south. It becomes like moving into the future. You cannot choose not to move into the future. Likewise, inside the horizon, you cannot choose not to move inward. The singularity becomes not merely a place, but an unavoidable future condition. That is difficult for the human mind to grasp because it violates our deepest assumptions about movement and choice. Yet the strangeness deepens. Imagine observing someone falling toward a black hole from far away. According to general relativity, you would never see them cross the horizon. Their clock appears to slow, their movements decelerate, light from them becomes redder, weaker, dimmer. They fade, freeze, disappear. To you, they asymptotically approach the horizon but never quite cross it. From their own perspective, however, nothing unusual happens at the boundary. They cross in finite time. This means two valid descriptions of the same event coexist. One observer sees endless slowing. Another experiences continued motion. Neither is wrong. Time itself has become observer-dependent in profound ways. This is where black holes stop feeling like exotic astronomy and begin feeling like cracks in reality. They reveal something fundamental. Human experience assumes shared time, shared sequence, shared causality. Black holes expose that these assumptions are local conveniences, not universal truths. Time can stretch, sequence can differ, reality can refuse a single narrative, and then we reach the deepest wound in the equations, the singularity. According to classical relativity, collapse continues until density becomes infinite and space-time curvature becomes infinite. Infinity in physics is usually a warning sign. It often means a theory has reached its limit. General relativity describes gravity beautifully at large scales. Quantum mechanics describes microscopic reality with astonishing precision. But inside singularities, these two frameworks collide and fail to reconcile. This failure matters, because singularities appear in two places of enormous importance. One lies inside black holes, the other lies at the beginning of the universe. This parallel should feel uncomfortable. The mathematics describing the interior endpoint of gravitational collapse begins to resemble the mathematics describing cosmic origin. In both cases, density becomes extreme, curvature explodes, known physics breaks down, and here the familiar scientific narrative becomes less comfortable. Black holes were once treated as cosmic endpoints, places where matter vanishes into unknowable collapse. But what if that assumption is incomplete? What if singularities are not endings at all? What if infinity is not the final answer? Because nature never truly allows infinities, many physicists suspect exactly that. Somewhere before infinite density has reached quantum gravity, the still unfinished theory uniting relativity and quantum mechanics must intervene. Something prevents the singularity from becoming literal infinity. But if collapse does not end in singular destruction, another possibility emerges. The inward collapse may transform into something else. Something expanding, something creating space-time instead of terminating it. And that possibility changes everything. Because the moment black holes stop being cosmic graves, they become something far stranger. They become potential wombs, not endings, beginnings, not destruction, genesis. And suddenly a terrifying symmetry appears. The most violent death in the cosmos begins to resemble birth. This is where the familiar picture begins to fracture in a more serious way. Up to this point, black holes can still be placed safely inside the human mental model of the universe. They are strange, certainly, but contained. Exotic objects scattered across galaxies, dangerous regions where physics behaves badly, rare anomalies in an otherwise understandable cosmos. That framing feels comfortable because it preserves hierarchy. There is normal reality. And then there are black holes. Ordinary physics works almost everywhere except inside these isolated extremes. But the deeper one studies modern cosmology, the harder it becomes to keep black holes isolated from everything else. Because the unsettling truth is that the same mathematics describing gravitational collapse also appears at the origin of the universe itself. That resemblance is not superficial. It is structural. Consider what the standard cosmological model tells us about the beginning. Roughly 13.8 billion years ago, the observable universe existed in an unimaginably hot, dense state. Not matter compressed inside pre-existing space. Rather, space itself existed in compressed form. Temperature was extreme. Density was enormous. Expansion began. Time as we meaningfully describe it emerges alongside this expansion. This story is often simplified into a visual metaphor. A tiny point explodes outward into empty space. But that image is deeply misleading. The Big Bang was not an explosion inside space. It was the expansion of space itself. There was no central location from which matter flew outward. No empty container waiting to be filled. Every region expanded relative to every other region. This distinction matters because it reveals how fragile ordinary intuition becomes near cosmic origins. Humans understand explosions because explosions occur inside rooms, atmospheres, planets, and stars. The Big Bang had no surrounding room, no external air, no outside observer. When people ask what existed before the Big Bang, they often unknowingly import assumptions from everyday life. Before sunrise, before birth, before construction. In ordinary experience, every event occurs inside time, but cosmology introduces a disturbing possibility. Time itself may have emerged with cosmic expansion, which raises a psychologically difficult question. What does before mean if time did not yet exist? Language begins to fail here. Not poetically, literally. Grammar assumes temporal structure. Human thought depends on sequence. Before, after, cause, effect. Remove time and cognition loses its scaffolding. This is already unsettling enough. But now notice something stranger. The mathematical description of the Big Bang if extrapolated backward, using general relativity alone, leads toward a singularity, infinite density, infinite curvature, a point where known physics collapses. Sound familiar? It should, because that is precisely what happens when a massive star collapses into a black hole. In both cases, the equations march toward infinity. In both cases, space-time reaches pathological extremes. In both cases, classical physics fails. This similarity creates an uncomfortable symmetry. At one end, matter collapses inward. At the other, space-time expands outward. Collapse, expansion, death, birth, inward singularity, primordial singularity. The mirror is difficult to ignore, and physicists did not ignore it. Over the decades, multiple researchers began asking whether these two singularities might not be separate phenomena at all. What if they are related? What if they are opposite descriptions of the same deeper process? This is where black holes stop feeling like isolated astronomical curiosities. They begin invading cosmology itself. To understand why we need to confront a hidden assumption almost everyone carries. Most people imagine the universe as the largest thing, the ultimate container. By definition, nothing contains the universe because the universe contains everything. This seems logically airtight, but there is a subtle problem. That statement depends entirely on how we define universe. Do we mean all observable space-time, all physical existence, our causal domain, a specific expanding region governed by shared physical constants? These definitions are not identical, and modern physics increasingly forces us to distinguish them. The observable universe is merely the region whose light has reached us. Beyond that horizon, space-time may continue far beyond observation. Cosmic inflation suggests this possibility seriously. According to inflationary theory, a tiny fraction of a second after the Big Bang space-time expanded exponentially faster than light. Not matter moving through space faster than light. Space itself stretching incomprehensibly fast. So fast that tiny quantum fluctuations were inflated into galaxy-scale structures. This theory explains observed cosmic uniformity remarkably well. But inflation carries unsettling implications. Some versions suggest inflation may never fully stop. Instead, regions of space-time continue inflating while localized pockets stop and form bubble universes. Each bubble becomes its own cosmic region, its own Big Bang-like environment, its own space-time domain. Already the concept of the universe begins losing singular meaning. Our universe may be one region among many, one bubble among countless others, one causally isolated domain inside a much larger structure. This idea is often called the multiverse, but the black hole hypothesis introduces something more specific, more intimate, more disturbing. Because instead of universes forming randomly in inflating space-time, black hole cosmology proposes something genealogical, parental. A universe gives birth to black holes. Black holes create new universes. Those universes form stars. Stars form black holes. New universes emerge. Reality reproduces. Pause there, because something profound just shifted. The universe is no longer a static structure. It becomes evolutionary, a cosmic lineage, generation after generation, ancestry on scales so vast that biology begins to feel provincial. We are familiar with inheritance in living systems. Parents pass traits to offspring. Selection shapes populations. Adaptations propagate. Now imagine similar logic applied to cosmology. Some theoretical physicists, including Lee Smolin, have explored models where universes that produce more black holes create more offspring universes. If physical constants vary slightly between generations, universes better at forming stars and black holes would become statistically more common. This idea is sometimes called cosmological natural selection. It sounds almost unsettlingly alive. Not life in the biological sense, but structure undergoing reproduction and selection, cosmos generating cosmos, reality inheriting reality. And if such models contain even a fragment of truth, then our universe may not simply exist. It may descend. We may inhabit a universe whose physical laws were shaped through countless ancestral generations. Gravity may have the strength it has not by accident, but because these constants favour star formation. Stars create black holes. Black holes create offspring universes. Selection continues. This does not prove the theory. Far from it. But it reveals something important. Modern physics no longer guarantees that the Big Bang was absolute beginning. Increasingly, our equations allow transitions rather than origins. Birth from prior structure. Emergence from deeper geometry. A universe arising from something older. Something beyond. This is where the emotional weight begins to change. Because the original question sounded speculative. What if our universe is inside a black hole? Interesting. Strange, perhaps even elegant, but now the psychological implication sharpens. If our universe was born inside a black hole, then the Big Bang was not the first event. It was our first event. There may have been history before cosmic history, a parent reality, ancient stars, galaxies older than our universe itself, not in our timeline, but in a larger chain of causality, events whose light can never reach us because they occurred outside our space-time. An unreachable prehistory. This introduces a uniquely unsettling kind of ignorance. Humans are accustomed to hidden pasts. We reconstruct ancient civilizations through ruins. We reconstruct stellar history through light. We reconstruct planetary formation through isotopes. But this would be different. This would be a past that is not merely lost. It is fundamentally inaccessible. Not hidden by distance. Hidden by ontology. It belongs to another reality, and the deeper problem is stranger still. Because if the Big Bang is the interior birth of a black hole, then what we call expansion may not be what we think it is. The entire cosmic narrative may need reinterpretation. Our universe may not simply be growing outward into abstract space-time. It may be the internal geometry of collapse viewed from the inside. And if that is true, then our intuitive picture of inside and outside is about to fail completely. This is where scale becomes psychologically dangerous. Not because the numbers become larger, though they do. Not because the mathematics becomes harder, though it certainly does. It becomes dangerous because the structure of reality starts resisting visualization altogether. The human mind survives by building spatial models. We imagine containers, boundaries, distances, surfaces, and directions. Inside, outside, up, down, near, far. These words are not just language, they're cognitive tools. They allow the brain to compress reality into something manageable. But black hole cosmology begins dismantling these tools one by one. Start with something deceptively simple. Imagine a sphere. Place yourself inside it. The sphere has an interior and an exterior. Even a child understands this. If you're inside, something else exists outside. Boundaries separate regions. The logic feels absolute. Now apply that intuition to the universe. If the universe exists inside a black hole, then naturally there must be an outside, something beyond our cosmic boundary, some parent space containing the black hole that contains us. This sounds intuitive, and this is precisely the trap, because the phrase inside a black hole does not mean what ordinary language suggests. A black hole is not a hollow cosmic shell with empty room inside. It is not a spherical container floating in larger space like a glass marble. The geometry is far stranger. In ordinary life, entering a region means travelling through space from one place to another, but in curved space-time, regions are not always arranged in intuitive spatial ways. Inside and outside stop behaving like household categories. This becomes easier to feel through an analogy, though even analogies fail quickly. Imagine a two-dimensional civilization living on the surface of a balloon. The inhabitants can move forward, backward, left and right along the surface, but they cannot perceive the third dimension. Their entire reality is the surface itself. As the balloon inflates, every point moves away from every other point. No point is the center of expansion from their perspective. Every observer sees all distant regions receding. This resembles our universe. Now ask a strange question. Where is the expansion happening? The two-dimensional beings might imagine they're expanding outward into some surrounding space. But from their lived experience, only the surface exists. The third dimension exists mathematically, but is inaccessible to them. Their physics may describe expansion perfectly without granting access to the higher dimensional embedding space. This is important, because our universe may be similar. We observe expansion internally, galaxies recede, space stretches, distances grow, but this does not automatically mean expansion occurs into something. That intuition is imported from everyday experience. Physics does not require an external spatial container. Now bring black holes back into the picture. From the perspective of an outside observer in the parent universe, a black hole forms through collapse. Matter falls inward. Density increases. A horizon appears. To them, collapse proceeds towards extreme compression. But from the internal geometry described by some theoretical models, that same process may correspond to the birth of an expanding spacetime region. Read that again carefully. The parent observer sees collapse. The interior observer experiences expansion. Same underlying geometry, radically different realities. This reversal is one of the most unsettling implications of relativistic cosmology. The direction of cosmic evolution may depend on perspective in ways the human mind resists. What appears as terminal collapse from one frame may appear as primordial creation from another, and suddenly scale unfolds in two directions at once. We are accustomed to thinking big by moving outward. Earth to sun, sun to galaxy, galaxy to cluster, cluster to cosmic web. Always outward. Black hole cosmology forces a different expansion. Outward from our universe into parent universes, then outward again. If our universe emerged inside a black hole within a parent universe, that parent universe may itself have formed inside a black hole in another universe, and so on. The scale no longer grows merely through distance. It grows through levels of reality. Nested existence. Layer within layer. Cosmos within cosmos. Each universe potentially vast beyond comprehension. Each capable of producing black holes, each black hole potentially generating new universes, each offspring inheriting physical laws with slight variation, each generation giving rise to stars, galaxies, collapse and rebirth. At first this sounds abstract, but pause and translate it emotionally. Human history spans a few thousand years of recorded civilization. Agriculture emerged around 12,000 years ago. Anatomically modern humans have existed for roughly 300,000 years. Complex multicellular lifespans hundreds of millions. Earth is about 4.5 billion years old. The universe, according to current measurements, about 13.8 billion. Already these numbers dwarf intuition. But nested cosmology changes the scale category entirely. Our entire cosmic age may be local, provincial, not universal age. Just the age of our space-time branch. Imagine discovering that the age of Earth was not the age of geology, but merely the age of one rock in an endless geological chain. That is the magnitude of conceptual shift being proposed. There may be ancestry beyond cosmic ancestry, prehistory beyond space-time, a lineage older than our universe's clock can express. And this leads to a disturbing consequence. The Big Bang may not represent creation from nothing. It may represent information loss across a horizon. This is where the physics becomes colder. In black hole, thermodynamics horizons carry entropy. Entropy measures information disorder, or more precisely, the number of microscopic states compatible with a macroscopic description. Black holes are not simple voids. They possess entropy proportional not to volume but to surface area. This result, associated with physicists like Jacob Bekenstein and Stephen Hawking, remains one of the deepest clues in theoretical physics. It implies something astonishing. Information about three-dimensional contents may somehow be encoded on two-dimensional boundaries. This gave rise to the holographic principle, the idea that the information describing a volume of space may be fully representable on its boundary surface. If true, our intuitive understanding of dimensionality becomes unstable. Volume may emerge from boundary information. Interior reality may be encoded externally. This sounds almost impossible until one realizes modern theoretical physics takes such ideas very seriously. Now apply that to our question. If our universe exists inside a black hole, could everything we experience as three-dimensional cosmic reality be encoded on a higher dimensional horizon belonging to a parent universe? Could stars, galaxies, nebulae, planets, your body, your memories, every atom in your blood all be emergent interior structure arising from information stored at a boundary you cannot access? The discomfort here is subtle but profound. We tend to think reality becomes more solid with scale. Larger structures feel more real. Planets feel more real than atoms. Galaxies feel more real than particles. But physics increasingly suggests the opposite. As we probe deeper, solidity dissolves into relations fields, probabilities, and geometry. The universe becomes less object-like and more informational, less material, more structural. And structure can be nested, encoded, projected. Emergent, this erodes something ancient inside human psychology, the belief that there is a final floor beneath reality, a base layer, solid ground. Instead, each deeper level reveals another abstraction, another hidden mechanism, another frame containing the previous one. This recursive expansion becomes emotionally exhausting, because where does it stop? At what level do we reach ultimate reality, a final universe, a fundamental substrate? An absolute origin? Black hole cosmology offers no comforting answer. In fact, it removes one. The Big Bang stops being the clean beginning we once imagined. It becomes a doorway, or perhaps a scar-marking transition rather than origin. And transitions imply prior states. Prior states imply larger systems. Larger systems imply deeper isolation. Because here is the real psychological cost of scale. Every expansion of reality reduces centrality. Earth became ordinary, the Sun became ordinary, the Milky Way became ordinary. Now even our entire universe may become ordinary. Not unique, not final, one interior region among countless others, a temporary bubble in a reproductive cosmic architecture. This is not merely bigness. It is decentralization taken to its logical extreme. Human insignificance no longer comes from living on a small planet in a large cosmos. It comes from existing inside one branch of a structure so vast that even universes may function as biological analogues of cells. And cells do not comprehend bodies, not because they lack intelligence, because the larger structure exceeds their scale of awareness. That possibility should linger, because the real question may no longer be whether our universe is inside a black hole. The real question may be whether beings confined inside a universe could ever know. And this is where speculation must slow down. Because ideas this large are seductive. The human mind is drawn towards grand architectures, toward elegant patterns that seem to connect everything. Black hole cosmology is powerful partly because it feels narratively satisfying. Singularities resemble beginnings. Collapse resembles birth. Universes producing universes creates a haunting symmetry. But symmetry alone is not evidence. Physics demands something colder than intuition. It demands equations, observations, and models that survive contact with measurement. So before going further into existential territory, we need to return to hard science. What does modern physics actually say? First, the standard cosmological model remains extraordinarily successful. The Lambda CDM model, our current best large-scale description of the universe, explains cosmic expansion, large-scale structure, the abundance of light elements, and the cosmic microwave background with remarkable precision. The cosmic microwave background itself is one of the strongest pieces of evidence for early universe cosmology. It is ancient radiation released roughly 380,000 years after the Big Bang, when the universe cooled enough for electrons and nuclei to combine into neutral atoms, allowing photons to travel freely through space. That faint afterglow still surrounds us today, stretched by cosmic expansion into microwave wavelengths. This radiation is not merely background noise, it is a fossil, a thermal memory of the early universe, when satellites such as COBE WMAP and Planck mapped it with increasing precision. They revealed something astonishing. The early universe was almost perfectly uniform. Temperature differences across the sky were tiny, only around 1 part in 100,000. Yet those tiny fluctuations mattered enormously. They became the seeds from which galaxies, stars, and eventually planets formed. This smoothness created a puzzle. How did regions on opposite sides of the observable universe become so similar if light had not had enough time to travel between them? Inflation offers a compelling solution. It proposes that before ordinary expansion, the universe underwent an extremely brief but violent burst of accelerated expansion. Tiny quantum fluctuations were stretched to cosmic scales. Regions now vastly separated were once causally connected. Inflation works well, but it also creates new questions. What caused inflation? Why did it stop? Did it stop everywhere? Some inflationary models suggest it may continue eternally in certain regions, generating new space-time domains indefinitely. This does not prove a multiverse, but it makes such possibilities scientifically discussable rather than purely philosophical. Now consider black holes. Observationally, black holes are no longer theoretical curiosities. We have overwhelming evidence they exist. Stellar mass black holes form from collapsing massive stars. Supermassive black holes reside in galactic centers. The one at the center of our Milky Way, known as Sagittarius asterisk, contains about 4 million times the mass of our Sun. The black hole imaged by the Event Horizon Telescope at the center of Messier 87 contains billions of solar masses. These are not speculative objects. They are astrophysical reality, yet the deeper mystery remains unresolved. What happens inside them? General relativity predicts singularities, but most physicists do not believe literal infinities exist in nature. Infinities often indicate theoretical incompleteness. Somewhere near Planck scale physics, where distances shrink to around 10 circumflex 35 meters, quantum effects become unavoidable. At these scales, space-time itself may cease to behave as smooth geometry. This is where the greatest unresolved problem in modern physics emerges. Quantum gravity. General relativity governs large-scale gravity beautifully. Quantum mechanics governs microscopic reality with unmatched accuracy. Each theory works extraordinarily well in its domain, but they do not fully reconcile. Inside black holes and at the Big Bang, both become necessary simultaneously. That union remains unfinished. Several approaches attempt to solve this. String theory suggests fundamental objects are not point particles but vibrating strings in higher dimensional spaces. Loop. Quantum gravity suggests space-time itself may be quantized, composed of discrete units rather than smooth continuity. Other frameworks propose emergent space-time arising from quantum entanglement. Despite differences, many share one important intuition. Singularities may not be real endpoints. Something happens before infinity. Something modifies collapse. This matters directly for black hole universe models. One influential line of thought involves quantum bounce scenarios. In some models, gravitational collapse does not continue forever. Quantum effects generate repulsive behavior at extreme densities, preventing true singularity formation. Instead of infinite compression, collapse reaches a minimum scale and rebounds. Bounce, not annihilation, not infinity, reversal. This idea also appears in cosmology. Some models propose the Big Bang itself was not the absolute beginning, but the bounce from a prior contracting phase. A previous universe collapsed, reached extreme density, then rebounded into expansion. Notice the pattern. Again and again, modern theoretical physics attempts to replace singular beginnings and endings with transitions. This does not prove universes inside black holes, but it keeps the door open. Another scientific clue comes from black hole thermodynamics. In the 1970s, Stephen Hawking made a shocking discovery. Black holes are not perfectly black. Quantum effects near the event horizon allow them to emit radiation now called Hawking radiation. Over immense timescales, black holes can slowly evaporate. This transformed black holes from eternal prisons into thermodynamic systems with temperature and entropy. But Hawking's result triggered one of the most disturbing problems in theoretical physics, the black hole information paradox. Quantum mechanics says information cannot truly be destroyed. But if matter falls into a black hole and the black hole eventually evaporates into thermal radiation, where does the information go? Destroyed, stored, encoded on the horizon, transferred elsewhere. Physics does not yet offer universal agreement. And this uncertainty is not a minor technical issue. It strikes at the foundation of reality. If information can be destroyed, quantum theory breaks. If information is preserved, black holes must encode far more than classical intuition suggests. Either way, black holes become even stranger. They are not simple sinks. They are information processing structures. That phrase deserves attention. Information processing structures. Not dead holes in space. Dynamic entities governed by entropy thermodynamics and quantum effects. Structures with hidden internal complexity. This scientific shift is profound because it makes black hole cosmology less absurd than it first sounds. 50 years ago, black holes were often treated as pathological oddities. Today they sit at the center of foundational physics. They may hold clues to quantum gravity, spacetime emergence, holography, and cosmic origin. Still, honesty matters. We do not have observational proof that black holes create universes. None. No telescope has observed a baby universe emerging beyond an event horizon. No experiment has confirmed universe reproduction. No equation universally accepted by the physics community demonstrates this conclusively. This idea remains speculative. Serious mathematically motivated speculation, but speculation nonetheless. And yet something important remains. Even without proof, black holes have already changed our understanding of reality in a deeper way. They have shown us where our current knowledge ends. That boundary matters. Because science often advances not by answering questions, but by locating the precise edges of ignorance. Black holes are edges. The Big Bang is an edge. Quantum gravity is an edge. At these edges, our most successful theories stop overlapping cleanly. And when multiple foundational mysteries converge around the same structures, physicists pay attention. Black holes sit at the intersection of nearly every deep unresolved question. What is space-time? What is information? Can singularities exist? How did the universe begin? Is gravity fundamental or emergent? Those are not small questions. They are structural questions about reality itself. Which brings us back to the original possibility. Suppose our universe truly was born from black hole collapse in a parent cosmos. Scientific caution demands we say we do not know, but scientific humility demands something else. We must admit that current physics does not rule it out, and that is unsettling enough. Because once a possibility survives the laws of physics, it stops being fantasy. It becomes a candidate architecture of reality, and candidates deserve to be taken seriously. Especially when they imply something far colder than mere cosmic scale, that our entire observable universe may be only a local event inside a much larger system we can never directly observe. What most people never realize is that the black hole hypothesis does not become unsettling because it makes the universe larger. It becomes unsettling because it changes what real means. That distinction matters. Human beings are comfortable with size, at least conceptually. We learn to accept that Earth is small. We learn to accept that the Sun is ordinary. We learn to accept galaxies beyond counting. These revelations were emotionally difficult, but they preserved something fundamental. Reality still felt direct. There were objects, distances, locations, matter moving through space. Black hole cosmology threatened something deeper. It suggests that what we call reality may be derivative, emergent, secondary, not the deepest layer. This is where the implications become uncomfortable in ways numbers alone cannot express. Consider your own experience right now. You feel located. There is a body occupying space, a room around you, air moving through lungs, light reflecting from surfaces into eyes. The world feels immediate and solid because sensory systems evolved to compress reality into stable objects and boundaries. Consciousness depends on this compression. Without it, coherent action becomes impossible. Yet physics has repeatedly shown that solidity is often a useful illusion. A table feels solid, but atomic physics tells us it is mostly empty space structured by electromagnetic repulsion. Time feels universal, yet relativity shows simultaneity depends on motion and gravity. Objects feel separate, yet quantum mechanics describes reality through interacting fields and probability amplitudes rather than tiny billiard balls. The deeper science goes, the less reality resembles perception. Black hole cosmology extends this pattern to its logical extreme. Perhaps even spacetime itself is not fundamental. This possibility has moved from philosophical speculation into serious theoretical physics. Many researchers increasingly suspect space and time may emerge from deeper informational relationships, rather than existing as primitive ingredients. Pause there, because human cognition depends so heavily on spatial intuition that this idea almost slips away before it is understood. Imagine telling a fish that water is not fundamental but emerges from something deeper the fish cannot perceive. The fish lives, moves, hunts, and survives entirely through water. Water defines every meaningful interaction. Asking the fish to imagine reality without water demands conceptual machinery it does not possess. Now consider humans. We think inside space. We remember through time. Every thought you've ever had was structured by location and sequence. So if space and time are emergent, then human consciousness may be cognitively trapped inside an interface rather than direct reality. Black holes intensify this suspicion because they expose situations where space-time behaves less like fixed structure and more like dynamic information. This becomes especially disturbing when we revisit the holographic principle. The holographic principle emerged partly from an impossible-seeming contradiction. Black hole entropy scales with horizon surface area, not volume. This suggests that the maximum information contained within a region depends on boundary area rather than interior volume. At first glance, this sounds like technical mathematics. Its implications are much stranger. It suggests three-dimensional experience may be encoded by lower-dimensional information. Interior reality may be emergent. Volume may be a reconstruction. The inside may not be primary. If this principle extends beyond black holes, then our universe itself may be holographic in deep ways. That does not mean reality is fake. It means our ordinary intuition about dimensionality may be incomplete. And if our universe is the interior region of a black hole, then a disturbing reinterpretation emerges. Everything we experience may be the internal unfolding of boundary-encoded information inherited from a parent horizon. Not simulated. Not artificial. Still real. But real in a way more structural than material. This distinction matters because popular culture often reduces such ideas into simplistic claims that reality is an illusion. Physics says something subtler and more unsettling. Reality may be real, but not fundamental in the way we assume. Your experience exists. Matter exists. Stars exist. But the ontology beneath them may be radically unlike what perception suggests. This hidden implication changes something ancient in human psychology. For most of history, meaning was tied to centrality. Religious cosmologies placed humanity near the center of creation. Even secular thinking often preserves softened versions of this instinct. Humans search for significance by assuming privileged status, special purpose, or deep central relevance. Science has repeatedly attacked this instinct. The Copernican shift removed spatial centrality. Evolution removed biological centrality. Cosmology removed galactic centrality. Black hole cosmology threatens ontological centrality. Not only are we not central in space, our entire universe may not be ontologically central. It may be derivative output of processes occurring at deeper levels of reality. This produces a unique existential discomfort, because scale alone can still preserve uniqueness. A single precious universe in endless empty space still feels meaningful, but a universe that functions as offspring inside recursive cosmic reproduction feels different, less singular, less privileged, more process than purpose. And process is indifferent. Stars do not care that they burn. Gravity does not care that it collapses matter. Entropy does not care about civilizations. The cosmos operates without psychological accommodation. This is where the emotional pressure deepens. Human civilization feels enormous from inside human timescales. Empires rise, languages spread, religion form, wars redraw maps. Generations inherit stories and institutions. Entire lives feel vast from the inside. But compare civilization to cosmic timescales. Recorded history spans roughly 5,000 years. The age of agriculture around 12,000. Modern industrial civilization perhaps a few centuries. The digital era only decades. Against cosmic history, civilization becomes almost instantaneous. Against stellar lifetimes, barely perceptible. Against recursive universe lineages, perhaps indistinguishable from noise. This is not meant to diminish human meaning emotionally. It is simply a scale translation. The same way a heartbeat disappears inside geological time, civilizations may disappear inside cosmological recursion. That realization can feel cold. But the real implication is colder. If universes reproduce through black holes, then most universes may never host life at all. Life may be incidental, a byproduct. Stars form because physics permits gravitational collapse. Heavy elements form because nuclear fusion allows it. Planets emerge from leftover matter. Chemistry explores possibility. Somewhere rarely consciousness appears. Not as cosmic goal, as local accident. A temporary self-aware pattern inside vast impersonal dynamics. This idea feels harsh because humans instinctively seek teleology. Purpose, intent, direction. Black hole cosmology offers architecture without intention, structure without narrative, reproduction without desire, creation without creator in the familiar sense. And yet the implications deepen further. Because if our universe is inside a black hole, causality itself may have hidden asymmetries we cannot perceive. What if the constants of physics we treat as foundational are inherited traits? The fine structure constant, particle masses, gravitational strength, vacuum energy. Why do these numbers have the values they do? Physics still lacks complete answers. Some constants appear delicately balanced for the formation of stars' chemistry and complexity. Slight changes could produce sterile universes. This puzzle is often called fine-tuning. Black hole cosmology offers a chilling possibility. These constants may not be universal truths. They may be evolutionary outcomes, inherited parameters shaped through countless ancestral cosmic generations. If so, even the laws of nature may have history, not immutable absolutes. Descended characteristics. The emotional consequence is profound. Humans once imagined laws of nature as eternal truths written into reality itself. Now even those laws may be contingent, selected, inherited, mutable across universes. This destabilizes perhaps the deepest comfort science provided, the belief that beneath complexity lies timeless law. Instead, law itself may participate in cosmic history, and if laws can vary, then reality becomes stranger still, because the universe we inhabit may not merely be one universe among many. It may be one successful configuration among vast numbers of failed realities. Universes too short-lived for stars, too chaotic for structure, too weakly bound for galaxies, too hostile for complexity. Most cosmic branches may remain dark and barren. We happen to exist in one that allowed long-lived structure, not because it was designed for us, because only such universes produce observers capable of asking. This is the hidden implication black hole cosmology forces into view. The universe may not be built for consciousness. Consciousness may simply emerge where physics accidentally allows sufficient complexity, and that possibility carries a strange loneliness. Not social loneliness, cosmic loneliness. The loneliness of recognizing that meaning may not be built into reality. It may be something consciousness generates locally against overwhelming indifference. But even this discomfort is only the beginning. Because once we accept universes may exist inside universes, a larger question becomes unavoidable. What kind of structure contains all of them? The human mind can tolerate vastness only when vastness remains empty. Empty distance is manageable. You can imagine endless darkness between galaxies because emptiness feels passive. It contains nothing that demands reinterpretation. But once structure exists at larger scales, psychological stability begins to erode. Because structure implies hierarchy, hierarchy implies containment, containment implies levels above your own, and levels above your own force a dangerous question. What system are you actually inside? This is the largest escalation so far. Until now, we have treated black hole cosmology as a hypothesis about origin. Our universe may have been born inside a black hole. Strange, unsettling, perhaps even mathematically plausible. But the emotional pressure changes once we stop asking how our universe began and instead ask what kind of larger architecture would make such births possible. Because a black hole does not exist in isolation. It exists inside something, a parent universe. That parent universe must possess matter stars, gravity claps, and space-time structures capable of producing black holes in the first place. Already this implies something uncomfortable. The universe outside ours may obey physics similar enough to ours for gravitational claps to occur. Not identical, perhaps, but structurally compatible. Now pause and translate the scale. Everything humanity calls the universe, every galaxy in the observable cosmic web, every cluster, every void spanning hundreds of millions of light years may correspond merely to the interior offspring, generated by one gravitational collapse event in a larger cosmos. One event, one black hole. Not all black holes. One. That sentence is difficult to hold in the mind because human scale intuition fails completely. Imagine spending your entire life studying a single cell under a microscope, mapping every molecule, every organelle, every protein interaction, every chemical pathway. You build an extraordinarily detailed model of the cell and eventually conclude you understand biological reality. Then someone tells you the cell is not the organism. It is only one microscopic component inside something incomparably larger a body, with organs, circulatory systems, consciousness, behavior history, and environment beyond anything visible within the cell. That is the kind of conceptual humiliation black hole cosmology introduces. Our observable universe may be detailed beyond imagination and still remain only a local structure inside a larger reality. And here the scale becomes more disturbing, not merely because it expands, but because it compounds. Suppose the parent universe resembles ours in broad structure. It contains galaxies. Those galaxies host stars. Massive stars collapse into black holes. Each black hole potentially seeds a new expanding space-time domain. Those domains become universes. Each universe eventually forms black holes of its own. The architecture begins to resemble branching recursion, not a simple ladder, a proliferating tree. Cosmic genealogy, branches spawning branches, universes producing descendants across unimaginable timescales. Try to visualize the implication. Do not focus on numbers, focus on multiplication. A single universe may produce millions, billions, perhaps vastly more black holes over cosmic history. If even a fraction generate offspring universes, one universe could produce astronomical numbers of descendants. Each descendant produces more. Each generation branches further. The growth becomes explosive, not in physical space, in ontological count. Reality multiplies. If such a system exists, then the total number of universes may exceed human numerical intuition almost instantly. This is where language begins breaking. Humans use words like million, billion, trillion with casual familiarity. But these numbers remain psychologically hollow. Even a billion seconds equals more than 31 years. A trillion seconds exceeds 30,000 years. Large numbers quickly outrun emotional comprehension. Now attempt to imagine numbers of universes generated recursively across cosmic generations. The mind does not scale, it saturates. At some point, many collapses into abstraction, and abstraction itself becomes part of the horror. Because incomprehension is not merely ignorance, it is structural limitation. The brain evolved to track social groups nearby terrain threats, resources and survival windows measured in days or seasons. It was not built to model recursively branching cosmological architectures. This cognitive mismatch matters. Because once scale exceeds cognition, intuition becomes actively misleading. You begin thinking in simplified metaphors because direct comprehension is impossible. Forest, tree, branch, cell, organism. Useful metaphors. Still insufficient. The reality may be stranger, because the parent structure needn't resemble biological branching at all. It may be something more alien, a higher dimensional space-time landscape, a quantum gravitational manifold, an eternal inflation field generating causal pockets, or something no current mathematics fully describes. This is where existential discomfort deepens into isolation, because the larger the containing structure becomes, the less likely meaningful interaction becomes between its regions. Consider our own universe. Even here, communication is brutally constrained by light speed. Signals take minutes across the solar system, years across nearby stellar neighborhoods, hundreds of thousands of years across our galaxy, millions across intergalactic space. Civilization already lives inside a causal prison defined by relativity. Now scale outward to universes. If universes are causally separated by event horizons, then no information passes between them. Not because communication is difficult, because causal structure forbids it. This distinction matters. There are things humans cannot do because of engineering limits, and there are things reality itself forbids. Event horizons belong to the second category. No engine solves them. No civilization bypasses them through greater intelligence if causal structure fundamentally blocks signal return. This means something profoundly lonely. If other universes exist, they may be forever inaccessible. Not hidden by insufficient technology, hidden by ontology. There may be infinite cosmic ancestry beyond us, and we may never observe even one direct trace. This transforms ignorance into permanence. Human history is filled with hidden frontiers later revealed. Continents once unknown were mapped. Planets once unseen were discovered. Galaxies once invisible became measurable. Each frontier eventually yielded to better tools. Black hole boundaries may be different, not unsolved, unsolvable from within. There is a psychological severity to permanent epistemic limits. Humans tolerate mystery best when mystery implies future discovery. Tell people a question remains unsolved and hope survives. Tell them a question may be fundamentally unanswerable and something deeper shifts. Curiosity meets a wall, and walls matter, because every civilization is built on assumptions about knowability. Science itself depends on the belief that nature can be interrogated through observation, inference, and experiment. But black hole cosmology hints at a category of truth that may exist while remaining permanently inaccessible to internal observers. Truth without observability, reality beyond evidence. Not because evidence is absent, because evidence cannot cross the horizon. That possibility is deeply unsettling to scientific psychology, and yet there is an even darker implication. Suppose our universe is not merely inside a black hole, but typical, ordinary, unremarkable. Then our cosmic environment may not be rare. There may be universes everywhere in the parent structure constantly forming through gravitational collapse. Some may die quickly. Some may inflate endlessly. Some may possess radically different constants. Some may host chemistry incompatible with life. Some may contain no stable matter at all. The overwhelming majority may be sterile, silent, dark. This returns us to a familiar cosmic pattern. Emptiness dominates. Just as most of our universe is vacuum, most of meta-reality may be lifeless. Even among universes, structure may be rare, consciousness rarer still. This realization intensifies human smallness in a new direction. Not only are we small within our universe itself may be small within reality. And not only small, disposable, one branch among countless branches, one event among uncountable collapses, one brief luminous pocket in a system too vast to notice us. Notice how different this feels from traditional cosmic awe. Ordinary astronomy makes humanity physically small. This makes us ontologically local, temporary not just in time but in level, embedded within embedded structures, nested beyond comprehension. And this produces perhaps the deepest existential escalation yet. The question is no longer how large is the universe. The question becomes at what level of reality does our existence actually reside? We assumed the universe was the stage. Now it may be only a chamber inside a larger structure. That structure perhaps inside another. And if this recursion continues, something terrifying begins to emerge. There may be no final outside. No ultimate frame, no highest level, only deeper containment, endless nesting, reality inside reality inside reality. And if that possibility is even remotely true, then human civilization is confronting something more unsettling than vastness. We are confronting the possibility that reality has no final horizon, only larger ones. There is a peculiar comfort in human scale, not because life is easy. Human history is full of war, famine, disease, grief and loss. Civilizations rise with confidence and collapse with astonishing speed. Empires once believed eternal now survive only as weathered stone-fragmented manuscripts or archaeological dust. Entire languages disappear, religion transform, borders shift, names vanish, even memory decays. And yet, despite this impermanence, human life feels large from the inside. A single year can feel transformative. A decade can feel immense. A lifetime can contain love, suffering, ambition, regret, creation, and memory dense enough to feel like a complete universe. This is not illusion. It is scale-dependent meaning. From the inside, human existence matters profoundly because consciousness experiences time locally. A child waiting for morning experiences eternity in a single night. An elderly person looking backward may feel decades collapse into moments. Psychological time and cosmic time are not the same thing, but black hole cosmology forces these scales into collision, and that collision is difficult to survive emotionally without distortion. Because once reality is understood as nested cosmological structure, human civilization begins shrinking in a way that ordinary astronomy never fully achieved. Astronomy already humbled us physically. Earth became one planet among many. Humanity became one species orbiting one star among hundreds of billions inside the Milky Way. The observable universe became home to hundreds of billions, perhaps trillions of galaxies. That alone feels overwhelming, but there remains a subtle comfort. Even in vastness, our universe still feels like the ultimate arena. Everything meaningful occurs somewhere inside it. Black hole cosmology removes that comfort. Now even the entire observable universe becomes local, provincial, something akin to one cosmological region inside a larger biosphere. And this changes the emotional meaning of civilization itself. Consider the total duration of recorded human history, roughly 5,000 years, measured against the age of Earth that is microscopic, measured against stellar lifetimes nearly invisible, measured against cosmic evolution effectively instantaneous, and measured against recursive universe lineages, civilization may vanish into statistical irrelevance. This is not poetic exaggeration. It is scale translation. Imagine an intelligent bacterium living inside a droplet of water. Suppose that bacterium builds culture, communication, cooperation memory. Suppose entire bacterial civilizations rise and fall within milliseconds. From inside that timescale, history feels immense. Revolutions matter, relationships matter, identity matters. Now compare those millisecond civilizations to the lifetime of the organism containing the droplet. Their entire history becomes almost imperceptible, not meaningless, just nearly invisible at larger scales. This analogy is imperfect but emotionally useful. Human civilization may occupy a similarly compressed temporal window inside larger cosmological structures, and the discomfort deepens. Because humans rarely seek only physical survival. We seek significance, meaning, legacy, continuation. We build monuments because we want permanence. We write because we want memory to outlast flesh. We create institutions to extend influence beyond individual lifespan. Civilization itself can be interpreted as a resistance against disappearance, against entropy, against oblivion. But black hole cosmology introduces a perspective where even civilizations become thermodynamic flickers, temporary self-organizing structures emerging inside one tiny branch of one universe among countless possible universes. This perspective does not merely make humanity small, it attacks narrative centrality. And humans are narrative creatures. We interpret life through stories, origins, journeys, purpose, destiny. Stories allow suffering to feel meaningful because they imply direction. Even secular narratives preserve this structure. Progress, advancement, civilizational ascent, technological transcendence. The future is expansion. But what happens to those stories when the cosmic backdrop changes? Suppose humanity survives extinction risks. Suppose civilization lasts thousands, even millions of years. Suppose we colonize planets, engineer stars spread across galaxies. To the human imagination that feels like ultimate triumph, galactic civilization, a species overcoming cosmic fragility. Yet against the scale we are now considering, even that triumph begins to shrink. A civilization spanning a galaxy still remains trapped inside one galaxy. A civilization spanning multiple galaxies still remains trapped inside one universe. A civilization mastering relativistic engineering still remains bound by causal horizons. No technological sophistication automatically grants escape from space-time structure. This is where human ambition collides with physics. Humans often assume sufficiently advanced intelligence can overcome any barrier. History encourages this belief. Mountains were crossed, oceans navigated, diseases cured, information transmitted globally. Problems once considered impossible became engineering challenges. But event horizons are not engineering problems in the ordinary sense. They are structural boundaries, not walls to break, causal limits to existence. This means even the most advanced civilization conceivable inside our universe may remain permanently unable to access the parent reality, if such a reality exists. Pause there, because this creates a subtle collapse of civilizational fantasy, not collapse of hope, collapse of scale. The largest imaginable human achievement may still remain cosmically local, bounded, provincial, a sophisticated culture inside one causally enclosed branch. This realization carries a strange loneliness, not because we are alone biologically. There may be intelligent life elsewhere in the universe. There may be civilizations far older than ours, but even a universe filled with intelligence would remain enclosed inside the same deeper structure. The loneliness is ontological. Everything conscious inside our universe may share the same confinement. No species escapes. No intelligence transcends causal architecture simply by becoming smarter. This universality of confinement changes how we think about knowledge. Human civilization often frames ignorance as temporary. There are unanswered questions, but future science will solve them. That assumption has powered extraordinary progress. Yet black hole cosmology introduces a different category. Questions whose answers may exist, but remain forever inaccessible from within. What lies outside our cosmic horizon? What preceded our Big Bang? What structure birthed our space-time? These may not be difficult questions. They may be forbidden questions. Not forbidden morally, forbidden structurally. There is a profound difference. Difficult questions inspire effort. Forbidden questions inspire humility. And humanity is not naturally comfortable with humility at civilizational scale. We build telescopes to see farther, accelerators to probe deeper, equations to unify forces. Again and again, science expands accessible reality. But what if accessible reality has hard limits? What if there are truths no internal observer can directly verify? Then civilization confronts something ancient. Not ignorance. Boundary. Boundary has psychological weight because it introduces finitude into curiosity itself, a horizon that knowledge approaches but cannot cross. This can feel oppressive, yet there is another way to see it. Boundaries create perspective. Meaning often emerges not from infinite access but from finite locality. Human love matters partly because lives are finite. Choices matter because time is limited. Experiences matter because they end. Similarly, perhaps, civilization matters not despite cosmic smallness but partly because of it. Still, that reflection comes later. For now, the scale continues expanding, because human centrality has collapsed in stages, spatially, biologically, cosmologically, now ontologically, and once ontological centrality collapses, a new question emerges. If our universe is merely one local region, what larger system governs all such regions? Not just parent universes, the architecture beyond them, the deeper framework from which universes themselves arise. Because the uncomfortable possibility is this: even the parent universe may not be the top level. It may also be inside something larger, and the real problem's even stranger. Until now, the parent universe has served as a kind of conceptual anchor. Even if our universe exists inside a black hole, at least something larger still feels familiar enough to imagine. A bigger cosmos, more stars, more galaxies. Another version of spacetime operating beyond our horizon. That image preserves comfort because it merely scales up what we already know. But there is no guarantee the larger system resembles our intuition at all. In fact, the deeper physics goes, the less reason we have to assume reality remains understandable in familiar geometric terms. This is where the larger structure becomes genuinely difficult to picture, because we may be making the same cognitive mistake repeatedly. First, humans imagined Earth as the center because local perception felt complete. Then we imagined the solar system as the main architecture, then the galaxy, then the universe. Each time what felt complete became local. Each time the frame expanded. Each time the human mind resisted. Black hole cosmology suggests we may still be trapped inside another incomplete frame. The parent universe itself may not be fundamental. It may be another local region inside something even deeper. This recursive possibility is not merely philosophical play. It emerges naturally once singular origins are replaced by transitions. If a universe can arise from collapse inside a parent universe, then the parent universe requires its own origin or transition. Either the chain ends somewhere or it continues. Both possibilities are unsettling. If the chain ends, we must explain why reality terminates at a final level, why that level exists, why its laws exist, why anything exists rather than nothing. These are not scientific questions alone. They cut into metaphysics itself. But if the chain does not end, something perhaps even stranger appears. Infinite regression. No first universe. No absolute beginning. No ultimate outside. Only endless nesting or endless generative structure. Human intuition strongly resists infinite regress, because narratives depend on beginnings. Stories begin. Causes precede effects. Histories trace back to origins. We expect first events because cognition prefers causal closure. Without beginnings, explanation feels incomplete. Yet physics does not promise that reality must satisfy narrative instincts. Reality is under no obligation to contain a satisfying first chapter. Consider time itself. Humans experience time linearly, past behind, future ahead, memory in one direction, entropy increasing. But some approaches to quantum gravity suggest time may not be fundamental. Time may emerge from deeper relationships, correlations, or entanglement structures. If time is emergent, then asking for a first moment may be like asking where north begins on Earth. The question assumes a structure that may not apply at deeper levels. This possibility changes the emotional texture of cosmic origin. Instead of a first cause reality, may consist of self-consistent structure without external beginning, not created in time, simply existing as total architecture. That idea sounds abstract until you translate its psychological implication. Human life is deeply anchored to beginnings. Birth gives identity. Childhood gives narrative origin. Memory establishes continuity. Remove beginnings and something destabilizes. Identity becomes less object-like and more relational. reality becomes less historical and more structural. Black hole cosmology pushes toward this discomfort because nested universes blur the distinction between creation and transformation. Each birth may be another transition. Each transition may emerge from prior structure. Creation becomes recursion. This is where the larger system begins to feel alien, because once recursion becomes central, the architecture of reality starts resembling mathematics more than physical scenery. Not a place, a process, not a container, a generative rule. Human imagination struggles here because we instinctively seek landscapes. We want places to visualize, cosmic oceans, higher dimensions, infinite voids. But the larger system may not be spatial in any intuitive sense. It may be closer to a lawful generative structure from which space-time itself emerges. This possibility appears in several modern theoretical frameworks. In some approaches, space-time may emerge from quantum entanglement networks. In others, geometry arises from informational relationships. In still others, reality may be described through abstract mathematical structures whose physical manifestation appears only at certain scales. The unsettling pattern remains consistent, at deeper levels where it becomes harder to define. This matters because the black hole question implicitly asks where our universe exists. Inside what? But deeper physics increasingly suggests inside may itself be an emergent concept. That should feel disorienting, because it means even our language begins failing. We ask where the universe is, as though location remains meaningful beyond space-time. But location requires space. Space may be emergent, so the question may be structurally flawed, not wrong but incomplete. Human language evolved for local survival, not trans-space-time ontology. This is not a trivial limitation. It shapes thought itself. Every noun suggests objecthood. Every verb suggests sequence. Every preposition suggests spatial relation. Inside, outside, above, below, beyond. But deeper reality may not respect these categories, and this brings us to a darker possibility. The larger system may not simply be bigger than our universe. It may be fundamentally less accessible to human cognition than colour is to a creature without vision, not hidden by distance, hidden by representational limits. This idea produces a different kind of existential unease. Most people fear unknown things because unknowns may become known. But what about realities the human mind cannot adequately model even in principle? Not because humans are unintelligent, because cognition is finite. A dog cannot understand tensor calculus. Not through effort, not through training. The representational machinery is absent. Similarly, there may be layers of reality human cognition can only gesture towards symbolically, never intuitively inhabit. Black hole cosmology may be brushing against such layers. Our equations continue functioning deeper than intuition. Mathematics often travels where imagination fails. This has happened repeatedly in physics. Relativity predicted time dilation before humans could feel it intuitively. Quantum mechanics predicted non-classical behavior long before anyone emotionally accepted it. Mathematics became a lantern carried into conceptual darkness. But mathematics does not guarantee intuitive understanding. We may describe structures we can never fully picture. This matters because the larger system beyond our universe may already belong to that category. A describable reality beyond imaginable reality. Pause there. Because this may be the deepest shift so far. Human beings often assume reality and comprehension are closely linked. If something is real, eventually it can be understood. But physics increasingly suggests a painful separation. Reality may exceed intuitive comprehension while remaining mathematically coherent. That means the universe may be stranger than not only common sense, but even imagination itself can accommodate. And if so, the black hole hypothesis becomes more unsettling than a simple origin story. It becomes evidence that our perceived cosmos may be only one accessible slice of a deeper structure whose full architecture cannot be directly experienced. The larger system may exist. It may govern everything, it may contain the logic from which universes emerge, and we may never perceive it except through faint mathematical shadows. This deepens isolation in a new direction. We are not merely small inside reality, we may be cognitively local inside reality, bound not only by location but by the architecture of thought itself. And that realization leads toward a silence more profound than distance. Because beyond scale lies something colder, separation without communication, entire realities existing beyond all possibility of contact. Silence is often misunderstood as the absence of sound, but cosmic silence is something colder. It is the absence of exchange. No signal, no reply, no feedback, no evidence that anything beyond your horizon can ever acknowledge your existence. Human beings are social organisms, and because of that, communication sits near the center of psychological stability. Even solitude retains hidden connection. A person alone in a room still lives inside language, memory, culture, and inherited meaning. Complete isolation is difficult for the human mind because cognition assumes relationship. We understand ourselves partly through response, through interaction, through recognition. Now expand that principle to civilization. Science itself is a dialogue with reality. We ask questions through experiments. Nature answers through observation. Every measurement is in a sense a form of exchange. Light reaches telescopes. Particles leave traces. Radiation carries information across time and distance. The universe feels knowable because information moves. This is why horizons are so unsettling. An event horizon is not merely a region we cannot cross. It is boundary across which meaningful communication fails in one direction. And when we scale this from black holes to universes, silence becomes absolute. Suppose other universes exist. Not metaphorically, not mathematically alone. Actually, entire cosmic domains with their own space-time structure, perhaps stars, chemistry, maybe even consciousness. From our perspective, what would they look like? Nothing. No distant glow. No spectral signature. No signal. No background whisper. Nothing. This nothingness matters because humans often confuse invisibility with absence. If we do not see something, we instinctively treat it as unreal or irrelevant. But black hole cosmology suggests an uncomfortable possibility. Vast structures may exist while leaving no observational trace accessible from within our causal domain. Reality without evidence, existence without observability. This creates a severe philosophical tension because modern science is built on empirical access. Observation anchors belief. Measurement disciplines theory. Without evidence, science becomes vulnerable to speculation. And yet here physics forces humility. Some truths may be physically real while empirically inaccessible, not because instruments are weak, because causal structure forbids contact. This is profound shift. Human history trained us to believe unknown frontiers eventually yield. The deep ocean became mapped, the far side of the moon became photographed, invisible bacteria became visible under microscopes, radio waves became measurable. Gravitational waves, once theoretical, were detected by LIGO after travelling across space for over 1 billion years. Again and again, hidden reality became observable. Black hole boundaries threatened to break this pattern. Some frontiers may remain frontiers forever. This introduces a form of cosmic loneliness unlike ordinary loneliness. Ordinary loneliness is relational deprivation. Cosmic loneliness is epistemic isolation. The recognition that there may be vast realities beyond us that can never participate in mutual awareness. This is difficult to emotionally translate, so consider a simpler analogy. Imagine intelligent life evolving inside a sealed cavern deep underground. The species builds civilization, mathematics, philosophy, science. They map every wall of the cavern. They understand their environment with extraordinary sophistication. Eventually, through theoretical reasoning, they infer that a vast external world may exist beyond the rock. Oceans, atmosphere, continents, stars. They derive this indirectly, but the cavern walls are impenetrable. No signal enters. No signal leaves. The outside world may be real, but for them it remains permanently unreachable. What happens psychologically to such a civilization? Some reject the external hypothesis because it cannot be verified. Some accept it mathematically but feel no emotional connection. Others become haunted by it. Reality larger than accessible experience creates existential tension because consciousness seeks closure. We want complete maps. We want final answers. But closure may not be available. Black hole cosmology magnifies this tension to ultimate scale. Our universe may itself be the cavern. The cosmic microwave background, distant galaxies and observable horizons may not mark total reality. They may mark only the walls of accessible existence. Everything beyond remains causally sealed. There is another layer to this silence. It concerns intelligence. The search for extraterrestrial life often carries emotional hope. Perhaps we're not alone. Perhaps somewhere else consciousness emerged. Built tools ask questions looked upward with similar wonder. That hope remains scientifically open. But black hole cosmology reframes the meaning of not alone. Even if intelligent life fills our universe, all such intelligence remains trapped within the same ontological enclosure, shared confinement. No civilization escapes the horizon separating universes. No species, however advanced, casually walks into parent reality. This means the deepest isolation may be universal. Every conscious observer inside a universe may share the same prison, different worlds, same boundary. That idea carries strange emotional weight. It transforms cosmic loneliness into collective confinement. All minds inside our universe, human or alien, may inhabit the same sealed chamber of reality. And there is something even colder. Silence does not only exist between universes, it dominates within them. Look at the large-scale structure of our cosmos. Galaxies cluster along filaments, but between those filaments lie immense voids. Some cosmic voids span hundreds of millions of light-years with astonishingly little matter. Imagine travelling through such a region. No nearby stars, no glowing nebulae, no neighbouring galaxies dominating the sky. Only darkness punctuated by remote light so faint it barely interrupts the black. This is what reality mostly looks like. Not crowded, not vibrant, sparse, empty, silent. Humans evolved under bright skies, moving air biological noise weather ecosystems. Earth feels alive because it is saturated with interaction. Sound, movement, chemistry, growth, decay. Life creates constant exchange. The cosmos does not. Most of reality is quiet beyond emotional intuition. This quiet matters, because silence scales. Within galaxies, stars are separated by enormous emptiness. Between galaxies, distances become almost incomprehensible. Between clusters, larger still. Between universes, perhaps absolute. Each scale strips away expectation of interaction. Each expansion reduces exchange. At sufficient scale, isolation becomes structural. And this brings us toward a darker interpretation of consciousness itself. Consciousness may be the universe's rare local mechanism for generating meaning inside otherwise indifferent structure. Not purpose built into reality, local meaning generation. Temporary islands of interpretation inside overwhelming silence. Human thought resists this because we prefer universes where meaning precedes observers. But what if meaning emerges only where awareness appears? Then consciousness becomes both precious and fragile. Not because it changes cosmic architecture, because it locally resists silence. A mind perceives, interprets, remembers, connects. Meaning appears, then disappears. Civilizations do the same at larger scale. They build symbolic worlds against entropy. Culture becomes resistance against silence. Science becomes resistance against ignorance. Love becomes resistance against isolation. None of these abolish cosmic silence. They create local interruptions, brief luminous pockets. This realization can feel tragic, yet there is also strange dignity in it. Because finite consciousness generating meaning inside indifferent reality is not lesser because it is temporary. Still, the black hole hypothesis leaves one final pressure unresolved. Silence may separate universes, but silence does not eliminate relationship. A child may never meet distant ancestors, yet ancestry still shapes the child. Likewise, if our universe was born from a parent black hole, then the parent reality may remain forever silent, while still determining everything about us, its laws, its constants, its structure, its hidden inheritance, which leads to one of the deepest philosophical questions in cosmology. Even if we never observe the parent universe, are we already carrying its fingerprints? There is a subtle difference between isolation and abandonment. Isolation means separation. Abandonment implies intention. The universe, as far as physics can tell, does not intend, does not choose silence. It does not decide indifference. Gravity does not pull with malice. Entropy does not erase with cruelty. Stars do not burn for purpose. Black holes do not collapse in anger. These processes simply unfold according to structure, and yet human beings continuously interpret structure emotionally. We cannot help it. Consciousness is a meaning-making system. It converts events into narratives, patterns into significance, and randomness into story. This tendency is not weakness. It is the foundation of memory, culture, morality, and identity. Without narrative compression, human experience becomes incoherent. This becomes important when confronting cosmic scale, because the emotional weight of cosmology rarely comes from the equations themselves. It comes from interpretation. A number is neutral. Its implication is not 13.8 billion years, a scientifically precise age estimate. Emotionally, it means something else. It means the entire span of human civilization occupies a nearly invisible fraction of cosmic history. It means every empire humans considered ancient arose almost simultaneously when compared to stellar evolution. It means all human memory exists inside a razor-thin slice of time. The mathematics remains calm. The interpretation unsettles. Black hole cosmology intensifies this process because it transforms cosmological facts into philosophical pressure. Suppose for a moment that our universe truly exists inside a black hole. Suppose the Big Bang was not the first beginning but a transition from parent reality. Suppose physical constants were inherited through cosmic ancestry. Suppose universes reproduce through gravitational collapse. What follows emotionally, not what follows scientifically. Emotionally, at first many people experience loss of centrality, loss of uniqueness, loss of cosmic privilege. Human identity has repeatedly adapted to scientific decentralization, but not without resistance. Each major discovery removed another comforting illusion. Earth was not central. Humanity was not separately created from life. The visible cosmos was not all that existed. Matter itself was not solid in the classical sense. Each discovery reduced certainty, yet something curious happened. Meaning did not disappear. It changed form. This pattern deserves attention. Before modern astronomy, meaning often came from central placement. Humans mattered because reality revolved around them. But after centrality collapsed, new forms of meaning emerged. Meaning moved away from privilege and toward participation. We matter not because the cosmos centers us, but because we are conscious expressions of the cosmos. That shift may matter even more here, because black hole cosmology threatens centrality at its deepest level. If our universe is derivative, then meaning cannot depend on cosmic primacy. It must come from something else, from relation, from awareness, from experience, from interpretation. This is difficult because humans instinctively link size with significance. Large things feel important. Small things feel disposable. Cosmic scale exploits this bias. Against galaxies and recursive universes, human life feels negligible, but significance does not always scale with size. A neuron is microscopic relative to a brain, yet consciousness depends on neuronal structure. DNA molecules are tiny relative to organisms, yet they encode biological inheritance. Scale and importance are not identical. This observation offers a philosophical correction. Small does not mean meaningless. Local does not mean irrelevant. Finite does not mean trivial. This matters because black hole cosmology can tempt fatalistic thinking. If our universe is one branch among countless branches, why should anything matter? Why care about civilization, knowledge, ethics, beauty, or love? This question emerges naturally from scale shock, but it contains an assumption worth examining. It assumes meaning must be externally guaranteed, as if value only counts when validated by the cosmos. Why? The universe does not issue certificates of significance. Stars do not approve meaning. Black holes do not deny it. Meaning may not be something granted from outside. It may be something generated from within conscious systems. This does not make meaning fake. It makes meaning relational, emergent. Just as temperature emerges from particle motion and life emerges from chemistry, meaning may emerge from conscious interaction with reality. This perspective changes how cosmic insignificance feels. Instead of asking whether the universe cares about us, a different question becomes possible. What kind of meaning can conscious beings create inside indifferent structure? This question is quieter, less dramatic, more honest, and perhaps more resilient, because it does not depend on cosmic favoritism. It accepts scale without surrendering significance. Still, black hole cosmology leaves one emotional tension unresolved: inheritance. If our universe was born from parent reality, then we exist downstream from causes we can never fully access. This is not entirely unfamiliar. Human beings already live this way. Each person inherits biology, language, culture, and history from ancestors never personally known. Their choices shape us long after their deaths. We carry genetic instructions written by evolutionary history and cultural structures shaped by forgotten generations. We are products of hidden inheritance. Cosmology may operate similarly. Perhaps the physical laws we inhabit are ancestral traces. Perhaps constants are inherited constraints. Perhaps the structure of our universe carries fingerprints from parent collapse. This idea produces a strange intimacy with the unknown. The parent universe may be forever unreachable, yet its influence may already permeate everything. The atoms in your body, the strength of gravity, the possibility of chemistry, the existence of stars. All may reflect deeper inheritance. Silence, then, does not imply disconnection. It implies asymmetry. The parent universe may shape us without reciprocal awareness. That thought feels almost biological. Children inherit from parents before understanding them. They are shaped by causes beyond memory. Only later do they reconstruct ancestry through traces. Humanity may be doing something similar at cosmological scale, reconstructing parent structure through mathematical fingerprints, never meeting the source, only inferring it. This reframes science in a deeply human way. Science becomes more than prediction. It becomes ancestry reconstruction, a search for hidden causes, a method for reading the fingerprints of invisible origins. There is something beautiful in that. Not comforting exactly, but beautiful, because it suggests that curiosity itself may be one of consciousness's most profound responses to cosmic uncertainty. We do not know, so we ask. We measure, we infer, we build models, we revise them, not because certainty is guaranteed, but because understanding expands local meaning. Even partial truth matters, especially in vast uncertainty. And perhaps this is the philosophical shift black hole cosmology ultimately demands. Not despair, not false comfort. Humility. Humility before scale. Humility before unknown structure. Humility before cognitive limits. Humility before the possibility that reality exceeds not only current knowledge, but perhaps human intuition itself. Humility is often mistaken for defeat. It is not. Humility is accurate proportion. It is the willingness to see oneself clearly relative to something larger. And black hole cosmology offers perhaps one of the largest perspectives modern physics has produced. A universe that may not be ultimate, a reality that may be layered, origins that may be transitions, boundaries that may be absolute, meaning that may be local, consciousness that may be rare, inheritance that may be hidden. All of this converges into a quiet realization. Perhaps the deepest human strength is not dominating reality. It is remaining conscious within mystery, because the mystery is about to become even larger. The most disturbing possibilities in cosmology are rarely the loudest ones. They do not arrive as explosions or dramatic contradictions. They arrive quietly through mathematical consistency. A small implication appears inside an equation. At first it seems abstract. Then another result supports it. then a third. Slowly an uncomfortable architecture emerges not because anyone wanted it, but because reality keeps permitting it. This is where the final scale revelation begins. Not with size. With recursion, human intuition handles large structures poorly, but it handles recursive structures even worse. Vastness still allows containment. You can imagine an enormous ocean because the ocean remains one object. Recursion is different. Recursion destabilizes boundaries. It creates structures whose logic repeats across levels where each scale contains echoes of another. Black hole cosmology becomes truly unsettling when you follow its logic without stopping early. Suppose our universe was born inside a black hole. Suppose that black hole formed in a parent universe. Suppose the parent universe itself emerged inside a black hole belonging to another universe. Then the question becomes unavoidable. Where does it stop? At first, the mind searches for comfort through hierarchy. There must be a top level, a first universe, an ultimate external reality, a final frame containing everything else. But this impulse comes from narrative instinct, not physics. Physics does not guarantee terminal hierarchy, and if no final hierarchy exists, something extraordinary follows. Reality may be recursively nested without absolute beginning. Universe inside black hole inside universe inside black hole, generation after generation, perhaps indefinitely. Pause there. Because the emotional difficulty of this idea is not merely infinite size, it is infinite dependence. Nothing becomes fully self-contained. Each reality inherits from another. Each layer contains descendants. Each structure becomes both offspring and ancestor. Origin dissolves into chain. Chain dissolves into recursion. Recursion dissolves the need for a first local beginning. This idea feels deeply alien because human cognition depends on asymmetry. Parents precede children. Causes precede effects. Roots precede branches. We think through directed structure. Recursion softens that directionality into something more abstract. Reality becomes less like a line and more like a self-generating pattern. This is emotionally unsettling because beginnings carry psychological comfort. Beginnings imply explanation. They imply grounding. Remove the first beginning and explanation changes character. Reality no longer rests on a single founding event. It becomes structural rather than historical. And here the implications become darker, because recursion does not merely allow infinite ancestry. It raises more disturbing possibility, self-similarity. What if patterns repeat across scales? This possibility appears repeatedly in nature. Coastlines exhibit fractal complexity. Snowflakes express recursive geometry. Biological branching repeats from blood vessels to trees to river systems. Scale changes but structure echoes. Physics does not require cosmic recursion to be fractal, but the idea deserves contemplation. If universes generate black holes and black holes generate universes, then similar structural principles may echo across scales. Galaxies around black holes, universes around black holes, collapse birthing expansion, expansion generating collapse, cycles nested inside cycles. This does not imply literal repetition, but it suggests something psychologically destabilizing. The boundary between micro and macro may be less absolute than intuition assumes. Now follow this one step further. If universes can contain black holes that birth universes, then every black hole in our own universe becomes conceptually transformed. Look up at the sky. Scattered across our universe are countless black holes, stellar remnants, supermassive giants, dark regions surrounded by accretion disks hotter than stars. Most people see black holes as endings. Dead stars, gravitational traps, cosmic graves. But under black hole cosmology, every black hole becomes something else. Potential genesis, potential ancestry, potential universes. This changes the emotional meaning of darkness itself. A black hole no longer represents absence alone. It may represent hidden abundance, entire space-time regions inaccessible from outside, entire histories unfolding beyond horizons, entire cosmic futures invisible to parent observers. This means something extraordinary. Our universe may already contain future universes, not metaphorically, literally. Inside black holes currently scattered throughout cosmic space, new expanding realities may already exist under some theoretical models. If so, then the night sky contains not only stars and galaxies, it contains hidden cosmological futures, unseen universes, invisible descendants. This idea carries almost unbearable scale. Because black holes are not rare, astronomers estimate there may be millions to billions of stellar mass black holes in the Milky Way alone. Across the observable universe, the number becomes incomprehensibly large. Each one potentially a cosmic seed, each one potentially a boundary between parent and child reality. And if even a tiny fraction produce universes, the multiplication becomes staggering. Reality may not simply exist. Reality may proliferate, endlessly, relentlessly, silently. This leads to the final terrifying implication. Our universe may not be special even in architecture. It may be ordinary, a statistically typical offspring, one branch among uncountable branches, one generation in an endless reproductive cascade. That sentence carries a particular existential coldness. Human beings tolerate smallness more easily than ordinariness. Being small in a grand universe still allows uniqueness. Being ordinary inside infinite recursive structure removes even that comfort. Ordinary means replaceable. Ordinary means not central to the process. Ordinary means the architecture does not depend on you. Civilizations struggle with this emotionally because meaning often borrows from exceptionalism. Special nation, special species, special planet, special universe. Black hole recursion strips exceptionalism layer by layer. We may inhabit not the center, not a privileged branch, not a unique cosmos, but a common configuration inside an endlessly generative system. And then one final question emerges. If recursion truly has no end, what does outside even mean? The word begins collapsing under its own assumptions. Outside relative to what? Parent universe. Parent of parent. Highest frame. What if there is no highest frame? Then outside becomes relational, not absolute. Every outside is another inside. Every container is contained. Every horizon opens into another horizon. This is perhaps the deepest philosophical rupture in the entire hypothesis. Reality may not possess a final external viewpoint. No God's eye frame within physics. No ultimate spatial backdrop. No final container. Only nested relational structure. This idea is profoundly difficult for consciousness. Because consciousness longs for final perspective. We want the complete map, the total view, the full architecture. But recursive cosmology denies that comfort. There may be no final map accessible even in principle, only local maps within larger unknowns, and that realization produces a peculiar kind of vertigo. Not fear of falling downward, fear of endless context, every answer opening into larger structure, every horizon revealing deeper horizons. No final floor, no final wall, no final outside, only recursion, only structure, only endless descent into larger reality. And somewhere inside that endless chain on a small rocky planet orbiting an ordinary star, a species emerged that became aware enough to ask whether its universe was inside a black hole. That awareness changes nothing about cosmic architecture, and yet somehow it changes everything about experience. Because recursion may be infinite, but consciousness is local, finite, temporary, aware, and that finitude is what makes the final descent feel so strangely intimate. After enough scale, the mind stops expanding. It begins to quiet, not because reality becomes smaller, but because comprehension reaches saturation. There comes a point where additional vastness no longer produces sharper fear. Instead, it produces stillness. Numbers lose emotional resolution. Distance becomes abstraction. Recursion becomes silence. This is the quiet descent. We began with a question that sounded almost cinematic. What if our universe exists inside a black hole? At first, the idea carried the thrill of speculative science, strange but still manageable. Then scale widened. The familiar map fractured. Black holes stopped being isolated cosmic oddities and became possible origins. Universes became offspring. Reality became layered. Horizons became absolute. Recursion threatened beginnings themselves. And now, after all that expansion, something unexpected happens. The emotional centre shifts inward. Because no matter how vast the architecture becomes, experience remains local. You're still here, in a room, in a body, breathing, aware. That contrast deserves attention. The observable universe stretches across tens of billions of light years. Galaxies drift through expanding spacetime. Black holes consume stars. Cosmic microwave photons continue crossing ancient distances. Somewhere perhaps unseen universes branch beyond unreachable horizons. And yet consciousness never experiences those scales directly. It experiences moments, breath, memory, perception, a passing thought, a pulse, the warmth of skin, the sound of distant rain. This is not a contradiction. It is one of the strangest truths about reality. The largest known structure and the smallest lived experience coexist without cancelling one another. Human beings often assume cosmic insignificance should automatically erase personal meaning, but lived consciousness resists such reduction. Scale informs perspective, but perspective does not eliminate immediacy. A star dying in a distant galaxy does not reduce the reality of grief. Recursive universes do not invalidate love. Black holes do not erase tenderness. Cosmic architecture does not abolish experience. It reframes it. That distinction matters, because existential fear often emerges when scale is misinterpreted as negation. Small becomes confused with meaningless. Temporary becomes confused with worthless. Local comes confused with unreal. But reality does not operate by those equations. Most meaningful structures in nature are local. Life is local. Memory is local. Biology is local. Consciousness itself appears to be an intensely localized phenomenon, a temporary organization of matter capable of self-reference. Rare, fragile, and finite. That finitude may be precisely why experience feels vivid. Imagine consciousness without limits, without endings, without decay, without time pressure. Meaning itself might flatten, urgency might vanish. Value often depends on scarcity. Moments matter partly because they pass. Lives matter partly because they end. Civilizations matter partly because they are fragile. This does not romanticize mortality. It recognizes structure. Entropy creates loss but also contrast. Contrast creates experience. Experience creates meaning. Even in a universe nested inside endless larger realities, this remains true. There is something quietly humbling about that. Not triumphant. Not comforting in a simplistic way. Just honest. The cosmos may be indifferent, but indifference is not hostility. Silence is not cruelty. Scale is not judgment. Reality does not diminish us by being large. It simply is large. We supply the emotional interpretation. That may be one of the deepest lessons hidden inside cosmology. Fear often comes not from reality itself, but from the stories consciousness builds around scale. Humans evolved to survive middle-scale worlds, predator distance, shelter, weather, social bonds. The cosmos vastly exceeds those scales, so awe and discomfort are natural responses. But perhaps awe and humility are more accurate than terror, because the black hole hypothesis, unsettling as it is, reveals something profound. Reality may be stranger than intuition, deeper than perception, larger than imagination, yet still partially knowable. Even now, from a small planet orbiting an ordinary star, human beings have inferred cosmic expansion. Black hole, thermodynamics, gravitational waves, quantum structure, and the age of the universe. That achievement should not be underestimated. A finite species evolved from biological survival pressures and learned to reason about space-time curvature. That alone is extraordinary, not because humans are cosmically central, because awareness emerged at all. Because matter became conscious enough to ask questions about its own origin. That is worth lingering on. Atoms forged in ancient stars became chemistry. Chemistry became biology. Biology became nervous systems. Nervous systems became reflective awareness. And reflective awareness began asking whether its entire universe might be inside a black hole. In one sense, this changes nothing. Galaxies continue drifting whether humans understand them or not. In another sense, it changes everything, because awareness creates perspective. Perspective creates wonder. Wonder creates inquiry. Inquiry creates science. Science expands the boundary of the known even when the unknown remains vastly larger. Perhaps that is enough. Not total comprehension. Not final certainty. Just honest inquiry within finite limits. There is dignity in that. Quiet dignity. The dignity of consciousness facing mystery without demanding complete closure. The dignity of asking questions that may never receive final answers. The dignity of remaining awake inside uncertainty. Because perhaps the deepest truth is not that reality hides answers from us. Perhaps the deeper truth is that reality does not owe us completion, and still we look upward. Still we calculate. Still we wonder. Still we ask. That persistence says something important about consciousness. Even in the presence of horizons it reaches. Even in silence it listens. Even in uncertainty it seeks pattern. And now only one final thought remains. Not a conclusion. Only a lingering perspective. Perhaps the most unsettling possibility is also the quietest. That nothing about the night sky looks unusual. You can step outside on a clear evening and see stars scattered across darkness with the same calm beauty humans have seen for millennia. Constellations remain familiar. Light travels faithfully. The moon rises. The sky offers no visible warning that reality may be stranger than imagination can comfortably hold. And that may be the deepest mystery of all. Reality does not announce its complexity. The universe does not look like curved space-time. Black holes do not look like broken causality. Quantum mechanics does not look like probability fields. And a universe born inside a black hole would not look different from one that was not. That is what gives the question its strange power. If our entire cosmos exists inside a black hole, nothing in ordinary human experience would directly reveal it. Children would still laugh. Rain would still fall. Civilizations would still rise and disappear. Love would still feel immediate. Loss would still hurt. Consciousness would still awaken each morning into local reality, carrying no intuitive awareness of the deeper structure surrounding it. Perhaps that is fitting, because human life has always unfolded between two truths. The local and the infinite, the intimate and the incomprehensible, a heartbeat and a galaxy, a memory and cosmic time, a single thought and the architecture of space-time. We live at that intersection, not large enough to contain the cosmos, not small enough to ignore it, aware enough to wonder, finite enough to feel unsettled by the answer. Maybe our universe is the interior of a black hole. Maybe the Big Bang was not the beginning, only a horizon. Maybe countless universes branch endlessly beyond causal reach. Or maybe reality is stranger still beyond even these models. For now we do not know. And perhaps that uncertainty is not a flaw in the human story. Perhaps it is part of it. Because there is something profoundly human about standing inside partial knowledge and continuing to ask deeper questions. Not because certainty is guaranteed, but because awareness reaches naturally toward mystery. Tonight, somewhere above Earth, ancient photons continue crossing impossible distances. Black holes continue bending space-time in silent darkness. Galaxies continue drifting apart. And if our universe truly was born from collapse in some unreachable parent reality, then beyond every visible star lies a history we may never touch. A larger silence, a deeper horizon, an unseen outside, or perhaps only another inside. And as unsettling as that sounds, one fact remains quietly unchanged. You are here, a brief conscious pattern in cosmic time, made of ancient matter, thinking impossible thoughts about impossible scales. That too is part of the universe, or whatever larger reality gave rise to it. Maybe that is enough. Not certainty, not completion, just awareness. Just this strange and temporary miracle in which matter can look into darkness and ask what darkness is. And perhaps the final truth is not hidden inside black holes or beyond cosmic horizons. Perhaps the final truth is simply this. The deeper we look into reality, the less it resembles a place built for comfort. And the more it resembles something vast, silent, layered, and unfinished. Something with no final edge, no final center, no final horizon, only deeper structure, and deeper mystery. So if one night the stars feel slightly different to you, if the darkness between them feels less empty than before, perhaps that feeling is not fear, perhaps it is perspective, The quiet realization that reality may be far larger, far stranger, and far older than human intuition was ever meant to hold. And still, for one brief moment in cosmic history, you were able to wonder about it. Then the sky becomes silent again, as if it never answered at all.